everyone. Okay, so in this video, we are just going over basic introduction to integration. So what is integration, or also known as anti-differentiation? So anti-differentiation or integration is just the reverse of differentiation. An antiderivative of a function f of x is a function g of x such that just the derivative of g of x is equal to f of x, i.e., right? Antiderivatives. So example, the antiderivative of 2x would be x squared plus 2 or x squared plus 4, because if I were to differentiate these, I'd get 2x plus 0. If I was to differentiate this one, I'd get 2x, right? These are known as antiderivatives, right? So it just means whatever I'm doing to differentiate, I kind of do the opposite to then integrate my function. So just to note, there are an infinite number of antiderivatives for any function. So as I've shown to you there, right, you have y equals 2x. Well, I found two antiderivatives for them there, right? So there are an infinite amount of antiderivatives for a function. So we usually find the general antiderivative. This is known as the indefinite integral, right? And the indefinite integral would include a constant of integration denoted by plus c to represent the possible constant terms, right? So if we're looking here, if I was integrating that, right, so it'd be x squared, then plus c. And then what this plus c kind of represents, this plus c represents, you know, like the plus 2, the plus 4, the plus 10, plus whatever it is, right? So c kind of accounts for all them possible values. When we're integrating without bounds, you must include the constants of integration. So in the next video, we're looking at definite integrals and like upper and lower bounds. But for regular old integration, you always have to add the plus c. You always have to add the plus c, or else you'll lose like a few marks. So if f dash of x is the derivative of f of x, then the integral, so the integration is said or told to us by this little notation here. It's like a little skinny squiggly s, right? I'll go over where that notation comes from in a later video for area under the curve. But it's just the integral of the function f dash of x with respect to x is just f of x plus c. So, we can only integrate expressions of the form a to the xn. So what that just means is we can only integrate polynomials. We're only really integrate like kind of polynomials that are multiplied out. So I can't integrate something like x plus 1 times x. I can't integrate it like that, because in leaving cert integration, there's no product rule or quotient rule in leaving cert integration. But what I have to do is I have to then multiply this out. So that'd be x squared plus x, and then I can integrate this, right? Or if I have like the integral of 1 over x plus 1, I can't integrate that. Right? I can't integrate that because I can't write it as a standard polynomial here. But if I have, like, say, x squared plus 2x all over x, and I'm integrating that, well, that would be the same as the integral of divide x in, x plus 2. And I can integrate that. So all I'm saying is you need to make sure your expression is in regular old polynomial notation multiplied out. So if we have any brackets, multiply them out. And if you have any fractions, make sure you try and simplify, or else you cannot do it. So what is the steps for integrating a function? So the steps for integrating a function, the steps for integrating a function is just you add 1 to the power, and then you divide by that new power. So the integral of x squared will become x, increase the power by 1, power 3 all over 3 divided by the new power. The integral of 1 over x squared, that's the same as the integral of x to the power of minus 2. Increase the power by 1, it'd be x to the power of minus 1. Then divide by the new power, which is minus 1. So the answer would be minus 1 over x. Right? So increase the power by 1, divide by the new power, and make sure then to add your plus c. Okay. So just some rules of integration. So if I am integrating 1 over x, that's just the same as ln x. You actually don't really need to know it that badly for leaving cert anyway. Another rule here is, which we'll kind of get into it in a later video, but if I'm integrating the sum of two functions, so if I'm integrating f of x plus g of x, I can split this up to the integral of f of x plus or minus the integral of g of x, depending if I was adding or subtracting them functions. If I'm integrating a constant, I just add an x. And if I have a common factor within a polynomial, I can always factor that outside my integration notation. So what do I mean here? Say if I have the integral of 2x squared plus 4. And I notice, oh, I could factor out a 2 here. X squared plus 2. I can actually take that integral outside like that. And I can integrate this and then times it by 2. Do you have to? No. But it's just some things I'm just aware of. Fine. Let's have a look at some examples here. So, integrate the following functions. So, the integral of 3x squared plus 2x minus 1. So, that would be 3x increased the power by 1, which is 3 divided by 3, plus 2x increased the power by 1. So, remember, that's an invisible 1 there, increased by 1, 2 divided by the new power, 2. Then I have minus 1, integral of minus 1 will just be minus 1x. And this will simplify down to, the 3's will cancel here, the 2's will cancel here. X cubed plus x squared minus x. And that is my integral. And don't forget, plus c. Right? Here, root x times x plus 6. Now, again, like I said, there's no product rule, quotient rule, or anything in leaving cert integration. If you do applied maths, you might be able to figure something out. But in terms of leaving cert integration, there's not much we can do here. But we'll multiply out the bracket. So first, I'm going to then multiply this out. So x squared is the same as x to the power of a half. So I'm now getting the integral of x to the power of a half times x. That's going to be a half plus 1. So it'll be x to the power of 3 over 2. Plus x to the power of a half times 6, which is just 6x to the power of a half. Now we can integrate. Increase this by 1, then divide by the new power. So it'll be x to the power of 3 over 2 plus 1 is going to be 5 over 2. Right? 5 over 2. And then I am dividing then by 5 over 2. And then this would be 6x to the power of a half plus 1 is 3 over 2. You can check that in your calculator. Then divide by the new power of 3 over 2. So I am dividing by a fraction, flip and multiply. So this would be 2x to the power of 5 over 2 all over 5 plus 12x to the power of 3 over 2 all over 3. And then 3 will divide in here 4 times. And then I have to make sure I add my plus c. Right, here, again, no quotient rule for differentiation. So I need to split this up. So I can split this up here as the integral of 4x cubed over x squared minus 2x squared over x squared minus 5 over x squared. And then this will be the integral then of 4x minus 2 minus 5 times x to the power of minus 2. Increase the power by 1, divide by the new power, so it'd be 4x squared divided by 2 minus 2x minus 5 times x to the power of minus 2 plus 1 is minus 1 divided by minus 1. And I'm left with here 2x squared minus 2x plus 5x to the power of minus 1. And that is 2x squared minus 2x plus 5 over x. And that is my, oh, and what did I forget? Forgot my plus c, and add your plus c there. Right, so that is just regular old integration of polynomial functions. So now sometimes we can be asked to then find what that constant value is. So we're given the derivative of a function, we're asked to integrate it, and then we might have a point that's on the original function. So given that the derivative of 4x cubed minus 6x squared plus 8 minus 2, and the curve, so find the value of f of x, given that the derivative is equal to 4x cubed minus 6x squared plus 8x minus 2, and the curve passes through the point 2, 7. So this just means f of 2 is equal to 7. So when x equals 2, my original function is equal to 7. So let's integrate now. So my original function is going to be the integral of my derivative here, which is going to be 4x to the power of 4 all over 4 minus 6x to the power of 3 all over 3 plus 8x to the power of 2 all over 2 minus 2x plus c. And I am going to be left with here. Let me make the pen a bit bigger. And I'm going to be left with here x to the power of 4 minus 2x cubed plus 4x squared minus 2x plus c. And what do I know? That is my f of x. And what do I know about f of x? Well, when x equals 2, y equals 7. So I have 7 is equal to 2 to the power of 4 minus 2 to the power of 2 squared plus 4 times 2 to the power of 2 minus 2 times 2 plus c. And my left-hand side will be equal to 2 to the power of 4 minus 2 times 2 squared plus 4 times 2 squared minus 4. So I'm left with 7 equals 20 plus c. Therefore, c is going to be equal to 7 minus 20, which is minus 13. So, therefore, my function f of x then is going to be x to the power of 4 minus 2x cubed plus 4x squared minus 2x minus 13. And that is my original function there. Right, let's just look at some exam questions really quickly. From 2022, find the integral of f of x equals 2x cubed plus 5x plus 6. Find the integral. Well, that would be 2x to the power of 4 all over 4 plus 5x to the power of 2 all over 2 plus 6x plus c. And that will be equal to, so f of x is going to be equal to x to the power of 4 all over 2 plus 5x squared all over 2 plus 6x plus c. Stunning. Right, 2011, find the integral of x plus root x. That's the same as x plus x to the power of a half. This is going to be x to the power of 2 all over 2, increase the power by 1, and divide by the new power, plus x to the power of a half plus 1 is 3 over 2, divide by 3 over 2, and that's going to be x squared all over 2. Then x to the power of 3 over 2 divided by 3 over 2. So if I'm dividing by a fraction, flip and multiply. So it would be 2x to the power of 3 over 2 all over 3. Plus c. Plus c. Make sure to include your plus c. Right, 2014. Write down 3 distinct antiderivatives of this function. So I find 3 antiderivatives of this function. So let's just find what my integral is. It'll be x to the power of 4. The x to the power of 4 all over 4 minus 3x to the power of 3 all over 3 plus 3x plus c. And then essentially what we need to do here is we just need to change the value of c like 3 times. So one possible value will be x to the power of 4 over 4 minus x cubed plus 3x plus 1. That'll be 1. Plus 2. That'll be another one. Plus 107. Like, it literally could be anything. That's the third one right there. Explain what is meant by the indefinite integral of a function. So it just means we have to add our integration constant of c. Then write down the indefinite integral of the function in part 1. Well, that is just going to be x to the power of 4 all over 4 minus x cubed plus 3x plus c. There it is there. And finally, last one here, the graph of f of x cuts the x-axis at 3 points, 2, 0, a and b. Given that the derivative is this, show that the integral is this. So I'm going to integrate 6x squared minus 54x plus 109. And that will be 6x cubed all over 3 minus 54x squared all over 2 plus 109x plus c. So my function f of x is equal to 2x cubed minus 27x squared plus 109x, then plus c. Now, do I have any points here? Yes, I do. When x is 0, my function here, when I sub in 2 into my function, it equals 0. So 0 equals 2 times 2 cubed minus 27 times 2 squared plus 109 times 2 plus c. This all will be equal to positive 126 plus c equals 0. Therefore, c equals minus 126. So therefore, f of x equals 2x cubed minus 27x squared plus 109x minus 126. And that was what I was asked to prove there. Anyway, I hope this video was some help to you guys. And in the next video, we're going to be looking at definite integrals. Right, I hope this video was some help, and I'll catch you guys later. Bye.